Hello, welcome to week 3 of mathematical applications. Today we're going to be looking at using algebra through problem solving. All right, so my name is Mr. George. If you have any questions, I'm going to post this down at the Google Classroom and in the Google Drive for the class and such. And so, yeah, don't feel free to ask questions. Don't be scared to ask about any inquiries. So today we will learn about algebraic properties, comparative equation word problems, linear relationships, and their applications. So let's get into it. All right, so here's some important algebraic properties. So these are basically just rules and laws about algebra. So basically, the first thing that we're going to see here is that a plus b is going to be the same thing as b plus a. That's pretty obvious. So 5 plus 2 is going to be the same thing as 2 plus 5. And the same thing is going to happen around here with a times b is going to be equal to the same thing as b times a. So whichever order that you put these in, it's going to give you the same answer. Another thing, if we want to group addition with parentheses or groupings, if we group one set, for example, a plus b, and then add another c, it's basically going to be the same thing as if you group b and c and then you added a. And that's the same thing for multiplication. So if we group in a times b, right, and then we multiply c as an external factor, then it's going to be the same thing as if we group b and c and we multiplied a as the external factor. So that's basically what it's saying. So additive identity property and the multiplicative identity property, basically what it's saying is anything times 1 is going to be the same thing as itself, right? And anything plus 0, because they're adding nothing, is going to stay the same and be the inverse property of addition. So basically, if we have this integer x, right, and then we add the negative of that. So for example, if we have 5 minus 5, right? So these two integers, they're of the same magnitude. So both of them are 5, but this one is negative because it's in the negative direction. And any which number added by its negative is going to be 0. And we use this a lot to cancel out things and move things from one side of an equation to the other side of the equation. So the inverse property of multiplication is really important. So basically, if we have 5 times 1 over 5, so what these two, what they are they are inverses of each other. So it's basically 5 and 1/5. So they are inverses of each other. So if you multiply 5, so if you have 5/5, that's just going to be equal to 1 whole. That's just going to be equal to 1 whole. So if you have 6/6, right? So if you have 6/6, if you have 4/4, then that's just going to be 1 whole. That's basically what it's saying. So anything times reciprocal. So this is the reciprocal of this, right? 1/5 is the reciprocal of 5, and 5 is the reciprocal of 1/5. And anything times its reciprocal is going to be equal to 1. That's something very important. Another thing, the transitive property. So basically what this is saying, right? Am I recording? All right. So basically what this is saying is that if we have this any number, right? So if a equals b, right? And b equals c, then a is also going to be equal c, because if this is b, then b is also this, and then a equals c. So an illustration of this, so if we say 2 is equal to 4 divided by 2, right? And 4 divided by 2 is equal to 6 divided by 3. So then that means 6 divided by 3 will always equal 2, right? So that's basically what it's saying. I'm going to change the code. All right. So on to the next one. These are just basically the same thing, multiplicative identity and the multiplicative inverse. So these are basically the same. It's all of this. Here's a proof. All right, whatever. Okay. So here we have some examples, right? So some simple examples. We're going to use the properties of that we just learned. So we have 3x plus 29 is equal to 5. So in these operations, basically what you're going to want to do is you're going to want to find x, right? So you're going to want to look for x. So in order to look for x, we're going to have to combine like terms. For example, a like term here is going to be 3x. So this is a separate term than just the sole number. So we have 29 and 5, right? So something that we want to do is we want to combine these like terms. So for example, in order to do this, in order to clear this side, have only this term, we're going to subtract 29 from both sides. Positive 29, and if you remember, if you add the negative of the same number, it's going to be equal to 0. So we're going to subtract 29, and so that's going to give us the equation 3x equals negative 24, right? And so something that we're going to want to do is we want to do the opposite function. So 3 times x. So this is basically the same thing as 3 times x, right, is equal to negative 24. So what we're going to do in order to clear the 3 out from front of the x is that we're going to divide both of these sides by 3. So divided by 3, divided by 3. And so that's going to give us this fraction, right? So if we simplify the fraction, then that's going to make x equal to negative. Now, something that we want to do, so if we assume that the x value is the same thing for both of these, right? And we have this equation, 3x plus 29 is going to equal 5, right? And we have also this equation. This kind of looks pretty similar to this. So whenever we look at two different equations, and we have to look at how related they are to each other and how they look. So basically, what this just means, spoiler alert, is that 9x plus 87 is going to be the same thing as 3x plus 9 times 3. And so then that means that the outcome or the output of this function, 5, multiplied by 3, then that's going to be the same thing as if we multiply this side by 3. So that means that 9x plus 87 is equal to 3. Now we're going to do the same thing over here. So one thing that I would like you guys to notice here is that we have this weird symbol, right? And this symbol, if you didn't know, it's greater than or equal to. Yeah, no, it's equal to because of this little line down here, and we know it's greater than because whichever direction this thing is facing, like the little mouth, whichever direction, the way I learned it was an alligator, whichever way it's eating is the one that's greater than. So 5 and minus 17 is greater than or equal to 28. So now what this is saying is setting the condition, right? And we need to find in which condition n will make this side of the function greater than or equal to 28. And so here it's basically just the same thing. You're going to want to add 17 to both of these sides in order to clear up this space and combine like terms. And so that gives the equation negative 5n is greater than or equal to 40. So something that we need to see here is that if an inequality, which is any type of version of this, right, that's not equal to, is if an equality is divided or multiplied by a negative on either side, you must flip the sign to face the other way, right? So we flip the sign, and so in order to combine like terms, we're going to divide this by 5, greater than 45. So whatever this is divided by 5, divided by 5. That means that it's going to be 45 divided by 5, but you guys see, we flip this. This was in this direction, and now it's n is less than or equal to this fraction. So if we simplify the fraction, that just means that n is less than or equal to negative 9. All right, let's keep on going. So let's ask ourselves, can negative 8 be a solution to this inequality? No, because negative 8 is greater than 9. So I just need to. All right. So if we have the system of equations, right? So if we have this system of equations, so this is something that we didn't cover. So 6,000 is equal to BU plus 4,000, right? And then this equation is 600,000 plus 100 BU plus 400,000 is equal to what? So we have set this condition here, right? So it's going to be this is equal to this, and we also have this thing. So what we need to do is we need to look at the similarities when we collect these things. And I don't know if you guys notice, we have this equation, right? Which is also going to be equal to 6,000, but we have this equation, right? And so if we multiply this equation by 100, then that's going to be equal 100 BU plus 400,000. 400,000. That should be another zero. But you see here, we have this equation, right? Which is equal to um, 6,000, right? And so that's just going to be equal to this, right? So if we use the commutative property, right? So if we multiply this by 100, right? That's going to be the same thing as this. So these two are analogous. So if we look at this equation, right? This, we can plug this into this equation and by factoring. So when I talk about factoring, it's taking out a common multiplicative or divisional integer to simplify the expression. So basically what we are saying here is that um, if we multiply this by 10, then that's going to be for this. And since we have this for this, then we can just plug it into the equation, right? So, yeah, so we have 100 BU plus 4,000, right? And so since BU plus 4,000 is also equal to 6,000, right? We can just plug it in with 100. So that means that the final equation is basically just going to be for this value, right? It's going to be for this value plus this found value. It's going to be 600,000 plus 600,000, which is going to be 1,200,000. So that's basically just what I'm trying to say is that you have to look for similarities in these uh, multiplicative equations. So here we have existing equations, right? So what's basically saying is that we have an array of equations here, right? So this equation, which what we try to do in this equation problem is that we try to find a solution in which these two will be, or yeah, in which these two are a set of numbers in which both of these equations will be true, right? So if we do to the transitive property equality, we can substitute entire equations. So we want to solve for x, right? So if in this equation we have y equals 3x minus 1, and we have y itself right here, that means that we can just plug this entire equation to substitute for y, right? So that's what we're going to do with 4x plus 3x minus 1 to negative 8. And so we're just going to combine like terms. So 4x plus 3x and then minus 1 is equal to negative 8. And we're going to just add 1 on both sides. And so basically what that's going to say is going to be when we solve for x, and 7x is equal to negative 7, right? And so if we divide both sides by 7, that means that x is going to be equal to negative. That's basically what we're saying. All right, so here we have another equation, right? So we're trying to find the value of x and y, and we see that there is a coefficient in front of both of them, right? And so then it's not really going to be that easy in order to like substitute it in. I mean, I guess we could do some math, but here we're going to take a little bit. So by canceling out variables and eliminating them, isolate the variables of the values of each variable, right? You multiply this bottom one by the negative, we get this new equation, right? So because negative times negative positive and negative times positive negative and such, so we get this new equation down below. It's going to be 2x minus 2y. It's going to be the bottom, right? And so basically what that is saying is that we are just going to be adding these two in order to cancel out this variable, right? And in order to get this variable isolated. So we just add them both, and that's going to give us this new equation of 5x is equal to 15, right? So then if we move this over here, it's going to be x is equal to 3, right? So we already have the x value. So all we really need to do is we need to plug it into this equation up here. It's going to be 3 times 3 plus 2y is equal to 10. And then so if we add the like terms, it's going to be negative 9. So that's going to give us 2y is equal to 1. And we can just divide both sides by 2. And that's going to give us the y value is going to be 1 over. So that's basically how we do it. So here's another one. I'm going to skim over this. So for what value of k does the system have no solution? So for a system of equations for having a solution, x and y coefficients have to be proportional or equal, while the constant additive is different. So what is that is basically saying is that the coefficients are basically just the numbers in front of the x or y. So negative 6.4 is a coefficient, 4 is a coefficient, over here 3.2 is a coefficient, and k is a coefficient. Now we don't know what k is. We need to find which value k has to be in order for these equations to never be the same. And so the constant additive is different. So these two have to stay different. They have no x or y. So basically what we're going to do, we're going to move the ky over here by subtracting it, right? And then we're just going to multiply it by 2. And so that's going to give us this new equation for this one in order to substitute for this one. It'll be negative 6.4x is equal to ky minus 11.6. So if we see here, right, and if we take the first equation, right, basically what we see here is that it's almost perfectly analogous, right? So we have negative 6.4 and we have a negative 6.4 over here. And then over here we have a 4y and a 2k, right? And K could be anything, but if we see here that we see constant additives are not proportional, they're completely different. So in order for this those solutions, we need to have a value of K in which multiply by 2 and give you 4, right? This is going to be 4 equals to K. So yeah, we just solve for K, and K is going to be equal to 2. So for if K is equal to 2, then this is not solution. Okay, so let's go over some more examples. I'm not going to go over this one because it's pretty self-explanatory. You just have to substitute, which you can just substitute 1 plus r for u, and you can just put u, plug in u for each one of these to make it simpler and make it less bulky. Negative u, and then it gives us the equation negative 24 is u. You divide both sides by 3, and it's going to be u is equal to 8. And so because I already went over this in the class, right? It's 7 1 plus r, and since 1 plus r is also just plug u in, 7u is equal to, and then since we also know that u is equal to negative 8, I mean 7 times negative 8 is going to give us the answer to this equation. All right, so here is another thing. So in this equation, k is constant. So for what value does k in the equation have infinite solutions? So for it to have, for an equation to have infinite solutions, that means it has to be literally the exact same value on both sides. So it has to be like 2x minus 1 is equal to 2x minus 1, right? So that equation would have infinite solutions. So basically, it's just x equals to x, right? So that's basically what we're doing. Yeah. So something that I wanted to show you guys is the commutative property, right? Or the distributive property. So that's what I wanted to do. All right. So if we have a plus b times x, so we have this grouping inside of here, and we are multiplying this grouping by x, right? So something that we can do is we just distribute x into xa, and we have q, and we can multiply xb, right? So that's going to give us ax plus bx. I hope I explained that well. So we're just going to multiply a times x and b times x, and that's how we're going to do. And we can use this same property in order to multiply this out. So we're going to multiply x times k and x times 1 in order to simplify this equation. So that's just a property that you can use any which way, like anytime, anything. If you see something like this, remotely like this, you can just multiply it out and have this. So basically, when we simplify the equation, it's going to be negative 2 plus 10x is equal to negative 2 plus kx plus x. So basically, what we're going to do is we're going to establish that is the same on both sides. And we want the same on both sides. So that's good. So for what value of k does the equation have infinite solutions? So since they're on both sides, we don't have to worry about that. We can just cancel them out. And so that's going to leave us with 10x is kx plus x, right? And so since we have this, right, we want to know what value of k would it be in order to have 10x on this side, right? And so we can just do some simple algebra here. We can subtract x from both sides because this is the coefficient and we want to combine like terms. So that means that 9x is equal to kx, right? And so if you cross out the x's over here, that means that 9 is equal to k. So for if 9 is k here, right, that means that this equation would have infinite solutions for whatever value. All right, so we're going to look at the real life applications. You might be thinking, oh, when am I going to use this? Well, this is how we're going to use critical thinking. We're going to set equations up. We're going to visualize relationships, and we're going to use compound algebra. Let's hop right into it. So let's say Salvatore, we already went through this. Guys, I'm going to release these notes. I'm just going to go through them. It's just explanation. Okay, so I'll redo this. All right. So if we have, say, Triola's pork store is charging $21 for a leg of ham and $15 for a full board of gabagool. If the store sold 102 food items this weekend and made $1,932 in sales, how many of each type of item were sold? So basically, what it's giving us here is it's giving us the prices for each one of these food items, right? And we know how many of the food items were sold, and we know how much money was made. But using this, we can determine how many, or we know how many food items themselves were sold. Sorry. Well, using this information, we can just basically averiguate how many of each one of them. Because if we're trying to take inventory, we don't know, we can just use this. All right, so we're going to define some variables. Something that's very important when dealing with word problems that we want to define variables, and we want to define logic. So price of a leg is $21. The price of an actual board of gabagool is $15, and the amount of legs is we're going to set this equal to h because it's n, right? And so the amount of boards is going to be equal to g, right? And these are just arbitrary variables that we're going to set up, right? So total sales are going to be 1,932. Right? And the total food items that were sold are going to be 102. These are just things that we take from the actual question, right? So we're going to set up a system of equations when neither input or output values are given. So the input or output values are going to be the amount of legs or the amount of boards because they depend on each other. So here we're just going to use a little logic here. So the total sales is going to be equal to the price of each leg times the amount of legs that were sold plus the price of each board times the amount of boards that were sold. Right? So the total food items is going to be the amount of legs sold and the amount of gabagool that was sold. All right. So here we know the value of the total amount of sales, right? It's 1,932, and we know the price of each leg, which is 21. And we know the price of each board, right? And so we know the total amount of food items that were sold. We have this. So what we're going to do is we're going to use that same strategy where we multiply it by a coefficient in order to cancel out the coefficient. And so we have just one variable that we can solve for. Right? So we're going to multiply this by negative 15, and we see we have this new equation, right? We have this arbitrary number, minus 15h and minus 15g, and if you see up here, there is a 15g. So we can just add these two equations to create this new equation where there is no g, and we can just solve for h. So if we add 1,932 plus negative 1,530, it's going to give us 402 is equal to 6h, right? And so if we divide 402 divided by 6, it's going to be 67 equals h. So what that is saying is that we sold 67 legs of ham, right? And so if you plug this into the original equation here, right, it's going to be 21 times 67 plus 15g. We can just solve for the amount of boards of gabagool because we know the final cost, right? So if we subtract 1,407, both of these, which is what this equals to, you're going to have 525 is equal to 15g. So if we divide both sides by 15, it's going to give us 35 is equal to. All right, we're not going to do this. It's just basically the same thing. We just have to use log. I'm going to explain. All right, so basically what it is, we define our variable, sum an amount of. So I'm just going to read it. Carmela is taking 41 people for a banquet in 7 vehicles. Some of the vehicles can hold 7 people each, and the rest can hold 5 people each. Assuming all the vehicles are full capacity, how many of the vehicles can hold 7 people? So we define our variables here. We establish sum in the amount of people, and the amount of cars is constant, so only variables change. So the only variables that actually change are the amount of larger vehicles and the amount of smaller. So there's a lot of variation. You have 3 larger vehicles and 4 smaller vehicles, or you can have 1 large vehicle and 6 smaller vehicles. But there's only one situation in which you can take 41 people, right? So be sure to correlate the correct variable with the right coefficient. We establish how many total people, and how many total vehicles, and we just set up this is an equation. So total people is equal to the people with the cars, and we can add the amount of larger and smaller vehicles, and we just do the same method. We multiply by a coefficient, we add them, we isolate the variable, and get the amount of large. Okay, so we're going to go into new territory. Okay, so let's say AJ has 2 types of assignments for his class. The number of mini assignments M he has is 1 fewer than twice the number of jumbo assignments that he has. So jumbo just means he has big assignments and he has little assignments, right? So if he has 47 assignments in total, how many of each type of assignment does he have? So what we want to do here is that we want to establish the amount of mini assignments, which is going to be equal to N, and the amount of jumbo assignments, which is going to be equal to J. And so we know the total amount of assignments is going to be 47, right? Because it says here he has 47 assignments in total. And the total is going to be equal to mini plus the jumbo. So is equivalent to equal. So if we look over here, we always have to be looking at the actual language of the question, right? So the amount of number of mini assignments M, so we're saying that this variable M is equal to 1 fewer than twice the number of jumbo assignments, right? So if we establish this equation, right, so the total mini plus jumbo, we also can see, so M is equal to 1 fewer, which is represented by the -1 of twice the number of jumbo assignments. So twice the number of jumbo assignments, that just basically means he has 2 times the number of jumbo assignments twice the number of jumbo assignments. So basically, if he has a set amount of jumbo assignments, if you multiply that by 2 and then you minus 1, that's going to be the amount of mini assignments. So in theory, in actuality, he should have more mini assignments because or than jumbos. So yeah, so if we can set up this equation, right? Again, here we're going to see that here we have m, right? And we have m right here. So these are isolated variables. So we can just literally just plug this in. We can just plug in 2j minus 1 in as m. So if we plug that in, that is going to be 47 to 2j minus 1. We add 1, we combine like terms. It's going to be 48 is equal to 3j. We divide both sides by 3, it's going to give us 16 is equal to j. And since we have that, right, we can just plug 16 for j, and then we can just subtract 16 for both sides in order to make uh, the same variable, right? Or in order to combine like terms, right? So we subtract 16 from both sides, and so that gives us 31 mini assignments. So in truth, he had 31 mini assignments, and he had 16 jumbo assignments. So this is just how we have to do. We just have to learn how to plug different equations in order to get the same variable. Because in order to solve for a single variable, you don't want another variable in there because it's going to obtrude, and that's just going to be block in your path. So here we have a question. So already hired new staff for a total of 33,575 for his restaurant, right? So each waiter is paid 375 and each cook is paid $850. If he hired 3 times as many waiters as cooks, how many cooks did he? So we're saying here he hired 3 times as many waiters, right? So what is that saying? So first of all, before we get into any of the mumbo jumbo, let's establish our variables, right? So waiter pay is equal to 375, cook pay is equal to 850. Amount of waiters, we're going to set this equal as W, and amount of cooks is we're going to set this equal to C, variable C. And so the total money that he spent is going to be 33,575, right? So 3 times as many W as C. So basically, what this means is, in order to have the same number of cooks and waiters, you need to hire 3 groups of cooks. So then a set amount of of waiters that he has. So he has a large amount of waiters. He has a larger amount of waiters than he does cooks. So that means that if you have a set number of cooks, right, and you multiply that number by 3, then that's going to give you the same amount of waiters, right? And so that application of that is going to be that the waiters is going to be equal to 3 times C, right? Because that's just how many waiters there are. So that's basically what this is saying. You just have to really pay attention to the word that this uses. So 3 times as many waiters as cooks. That means that the waiters is a larger group. All right. I hope I explained this. So the total amount that he spends is going to be equal to the waiter pay times the amount of waiters plus the cook pay times the amount of cooks. And so we can just plug in the variables there, and then we know that W is equal to 3C, right? And in order to have only one type of variable here, as in the C, we can just plug this in, right? Have a W in here. So what we want to do is we want to plug in 3C. Instead of W, we're going to have 3C. And so that means that we only have C in this group. So we're going to add like terms, we're going to multiply this out, and then add this, that goes up to 1,975, and we're going to divide this by 1,975, and that's going to give you 17 cooks. So based on all of this, just plugging this in, you already have the amount of cooks that you hire, just based on all these data. That's how you're going to do it now. Okay, so this is a big one. All right. So if Livia wants to make tables and chairs, right? So each chair or table is made with the same number of wooden boards and nails. Each table is made with 17 boards and 34 nails. Each chair is made with 16 boards and 29 nails. So she has a total of 150 wooden boards and 330 nails. Now, the question that we want to ask ourselves is, does Livia have enough materials to make 3 tables? So Livia wants to make this set amount of tables and chairs, right? And she has a certain amount of boards and nails, but you also have to take into account how many boards it takes to make a table and how many boards it takes to make a chair. So let's define our variable. So right here, what this is going to represent is going to be wooden boards per table. So the amount of wooden boards per table is going to be equal to 17. Do I have a timer on this? minus 9. So this is also going to be, we have this other variable, nails per table is going to be 30. And we're going to set these more of these and so this one board per chair is going to be 6 because it needs 6 boards. Each chair is going to be 6 boards. And the nails per chair is going to be 27 because you need 27 nails per chair. And so then the max amount of wooden boards that we have are going to be 150 wooden boards because that's all that she has. And the max amount of nails is going to be 330 because that's all she has, right? And so the desired tables that we want is going to be 3, and the desired chairs that we want is going to be 9. And so the actual amount of tables, or the amount of tables, is going to be set equal to T, 1, 2, and the amount of chairs is going to be equal to C. So here we have this equation. So this looks a lot very wordy, right? But all this indicates is just log, right? So if we have the wooden board per table, right, times the amount of tables, right, and we have the wooden board per chair times the amount of chairs, all of this, it has to be less than or equal to the max number of wooden boards, because you can't go over the amount of wooden boards that she has because she can't get any more, right? It has to be less than, you have to use less than or equal to 150, right? And so it's just setting up that ratio. So she can use, if she did one table, right, it would be 17, 30 times 17. So that would be using 17 boards, and she can make a lot more chairs than that, right? But no, we just have to stick to this limitation, right? And so then we can establish the same logic with the amount of nails, right? We have the nails per table, which is T, and then the nails per chair times the amount of chairs. It has to be less than or equal to the max number of nails. So here we have 17. Oh, let me see how much time. All right. So 17. All right. So what we know here is that we know the amount of wooden boards per table is going to be 17. We know the amount of wooden boards per chair is going to be 6. And we have these variables. So it's T plus 6. So we're just substituting each one of these. We're using logic in order to substitute. So we can do the same thing over here with the actual values. We can only use less than or equal to 330 because that's all she has, right? And so then if we want to set this equation up and to see if this is going to be true, right, we're just going to plug in the desired number of tables and the desired number of chairs, because the tables, they either take up wooden boards or they either take up nails, right? So we want to see if we have enough boards and if we have enough nails. So we're just going to plug in both of these. And if these are true, if they are less than or equal to 150, then that means that she can, because she's not going to use all of the boards or all of the nails, right? But if it's more, if these values are more, then that's not going to be good. She doesn't have it. All right, so if we multiply this out, that's going to be 51 plus 54. And so if we see, and we multiply this out, it's going to be 102 plus 243. And so if we add these up, that means that if she wants to make 3 tables and 9 chairs, that means that she's going to use 105 wooden boards, right? And that's going to be less than 150 boards that she already has, right? And so then that means that she can be able to do it. Now, if we look over here, we multiply out the nails, right? So it's going to be the total amount of nails that she's going to use is going to be 345. She's using 345 nails, right? And so, yeah, so she's going to be using 345 nails, but she only has 330, right? So you can absolutely use 105 wooden boards, but this number is not less than or equal to 330. So that's going to be a no. So our conclusion is that Lydia has enough wooden boards, but not enough nails. Okay, so this is the last question. I'm going to set up a new call because this might end at really closely. So I'm going to set up just a video. This one's probably the hardest one. All right. So I hope you enjoyed this. I'm posting this. Yeah. Thank you guys. All right. Hello, guys. Welcome back. This is just going to be me presenting this last portion. All right. So I hope you guys remember everything from the last thing. Let's just get started. So here we have a very big and very important, very scientific question. So please pay attention. I will explain this to the best of my ability. And this is some pretty advanced level thinking stuff. So if you need to run this video back again, look at it back again and whatnot, feel free. All right. So what we are going to do today. Right? So Christopher will mix X millimeters of a 10% by mass sugar solution with Y milliliters of a 20% by mass sugar solution to create a 12% by mass sugar solution. If Christopher uses 100 milliliters of the 20% mass solution, how many milliliters of the 10% mass solution must he use? So that is a lot of words. That is a lot of numbers. All right. So basically what this is saying, right? So a solution, right? So the solution that we have right here. So a solution is basically just water and some stuff that you put into it. So if it's 10% by mass, right? So what does that mean? So that means that if you have, um, so yeah, here, let me explain. I think I explained this. So whenever faced with percentage questions, as in like 10% by mass, 20%, 12%, we have to consider the percentages as decimal. So what that means is, so we have a 10% by mass, right? And so what this 10% basically means is that we have 100 milliliters of sugar. It's not technically milliliters, but we're just going to count it as milliliters, right? So 100 milliliters of pure sugar water over 100 milliliters of just water, right? And so that's going to give us the 10%. So that's basically what that means. So that basically what that means is that there's 100 milliliters of sugar here for every 100 milliliters of water. That's basically what that 10% means. And so for the 20%, it's going to mean that there's more sugar, right? That means that there's a 20 milliliters of sugar for each 100 milliliters of water. So we're faced with the percentage question. So we just have to set up this equation. This is a good way to think about it. Is equal to the 10%. And so if we take the 10% and we divide it by 100, we get 0.10. So we have to consider these percentages as decimal because 10% is basically equivalent to 0.10, right? So that's basically this if we just solve for this, right? And let's define some of our variables, right? So we have X is going to be equal to the milliliters of 10% solution added, right? So that's the amount of milliliters that he puts in the mixture in order to create the 12%. So the way that creates the 12% is that he adds different amounts of the 10 and 20 because 10% is less than 12% and 20% is more than the 12%. So we have to mix and match the amount of different solutions, right? So is the milliliters of 10% solution added, and Y is going to represent the milliliters of 20% solution added, right? And so X plus Y is going to be the total final amount of milliliters. So we need to know this value because this number on the bottom here is the total final milliliter. That's something that we need to know. So let's define the problem with mass itself. So we have the volume, right? So if it's mass by sugar, that means mass. We can define it by mass, right? So what that means basically is we have these units here in volume, right? But we're just going to consider them to be mass because normally we consider mass of sugar when we weigh sugar. It's normally what, grams, right? So we're just going to consider them to be grams. So if it's 0.10, right, that would be the percent mass. But since we're working with 100 milliliters, right, we're just going to consider that to be 0.10 grams. We are just going to consider this as 0.10 grams. This is just an easier way to think about it, and it's an easier representation. So here we have these two. So basically what we are doing here is that we're going to add this cup. This cup has a little bit of sugar, right? It has water right here. We also have this cup, which has the same amount of water, but has more sugar. So what this represents is this is going to represent the 10% by mass sugar, and it's going to represent the 20% by mass sugar. So when we add that, when we add both of these, right, we are going to create a bigger cup, right? Or we're going to pour it into a bigger cup. But we have double amount of water because this is this water and this sugar. So this big amount of sugar is going to be this sugar and this sugar. So what we need to do is we need to find out how much of each of these we need to create this. Or we already have the amount of 10 milliliters of the 20% mass solution. So that means that we need 100 milliliters of this solution, right? And we need to find out that in order to create a certain amount of 12%, how much of this are we going to need, right? So we know we have 100 milliliters of 20% mass solution, or the 0.2 mass solution if we want to consider mass as in decimals instead of percentages. And how much of this we're going to need to create a set amount of 12% by mass distribution. So here we have percent. So mass is going to be equal to the percent, or in this case, the decimal times the volume, and it's going to be equal to the mass. Because we think about it, right? So percent is basically just a ratio of grams per of volume, right? So it's going to be grams over volume. So we have so here, that's basically just going to mean, so it's grams. I know we don't have that represented here, but that's just like the best representation. I think, yeah, this is, imagine this is equivalent grams. We're just going to say milliliters and grams. We're just going to say it's the same thing here. More likely than not, it's not, but we're just going to say that. So it's grams per milliliters. So if we multiply milliliters, that means that we're going to cancel this one and this one out. So what we are left with is grams, right? So that's just going to be equal mass. And that's why we are going to be using mass in this example. So if it's 0.10x is going to be equal to mass sugar by 10%. It's going to be the amount or the mass of the sugar that is afforded by this one. So we have over here, it's going to be 0.20y is going to be the mass sugar afforded by the 20%. Afforded just means given, right? So yeah. And 0.12 times the x plus y, if we remember the x plus y are going to be the milliliters of solution, right? So here we have the percentages, right? So 0.10 is going to be equivalent to the 10%, 0.20 is going to be equal to 20%, right? And so if we multiply them by the milliliters, which is what these represent, it's going to be the same thing. It's going to be equivalent to this equation. That's going to be the mass sugar. If it's 12.12 times x plus y, which is going to be the total amount of the final milliliters, that's going to give you the final mass. So mass I added is going to be the final mass because we're not adding or removing sugar in this equation, right? It's going to be the same amount of sugar that we begin with, the same amount of sugar that we end with. It's going to be the same amount of water that we begin with and the same amount of water that we end with, right? The only thing that's changing is the ratio, depending on how much water we have, right? So if we have this, right, the mass sugar by the 10% and the mass sugar by the 20% is going to be the final mass, right? And so we can have this. We already have these variables, right? Using logic, right? And so we just need to plug them in. We have established here that 0.10x is the percentage times the volume, right? And the volume is right here. We just plug all of these things in, and the final mass is going to be 0.12. If you can't see it there, I'm sorry. Can't see it there. I'm just going to, right? So if we have the final thing right here, 0.12x plus y is equal to the final mass. Yeah, it's going to be equal to that. So the final mass. So it's 0.12x plus y, right? So if we go on a little bit, yeah. So and oh my gosh, I'm so just gonna. Okay, so we have this equation, right? And so one thing that we have to understand is that we have x is defined for us. X here is defined for us because in the question it says if Christopher uses 100 milliliters of the 20% mass solution, how much milliliters of the 10% mass solution is going to use? So we already have this variable y, ml of 20% solution added. We already know this because we know that Christopher is using 100 milliliters of the 20% mass solution. So we already have y here, right? And so we can just plug 100 in because that's just the volume of it. We can just plug it in for y in this equation. And so what we are going to do is we're going to distribute it. Remember we have the distributive property 0.12x and 0.12 times 100. Remember we have the distributive property. And so we're going to multiply 0.20 by 100. 0.12x plus 12. So what we're going to do here is what we've always been doing since the beginning of the lesson. So it's going to be minus 1, 2. I mean, it's going to be minus 12. That's going to be minus 12 on this side as well. So what we're basically doing is we are adding like variables or like terms. So we're we're going to subtract 12 from both sides, and that's going to give us 0.10x plus 8 is equal to 0.12x. So what we're going to do here is that we're going to combine these like terms in order to get rid of this variable on this side. Because something that we always want to see is that if there's a bigger number on this side and a smaller number on this side, in order to get a positive number, we're going to have to subtract the smaller number from the bigger number. So this is the bigger number, we're subtracting the smaller number from. So yeah, and so that's going to give us 8 equals to 0.02x, because 0.12x minus 0.10x, this is just removing this decimal point, or it's basically just removing this 1. So it's going to give us 0.02. And so what we have to do is we have to divide both sides by 0.02. So what that's going to give us is going to give us the final answer. So we always want to define our answers using units. So that's going to come up to be x equals 400 milliliters, because 8 divided by 0.02 is going to be equal to 400. And that's how we solve the equation, right? We take physical properties that we know, and we have to define them using easier ways. Because we did this with percentages. After all, percentages are just ratios. They are ratios that represent a certain amount for a certain amount. And we can use these ratios in order to establish physical constants. What we did here is 100 milliliters. We just plug that in, but we already know by logic, because the mass acts final mass, we can just use that property and apply our logic by the mass sugar added by the 10% plus the mass sugar added by the 20% is going to be the final mass. Because you can't add or subtract any of this, you're just changing the ratio. All right. So what this is saying is that in order to create a 12% by mass sugar solution, you need to use 100 milliliters of the 20% mass solution and 400 milliliters of the 10%. So this is very useful, and when you're trying to decide, when you're trying to make concentration. So what this is basically it's just a concentration question. What concentration is, it's just the amount of something per an area. So if you have a smaller amount of sugar here for the same area over here. So these two, they technically have the same area because they have the same volume of water, right? But this one has less sugar in the same volume. This one has more sugar in the same volume, so that it has concentration. So that's why we use a lot less of the 20% mass solution and a lot more of the 10% mass. All right. So I hope you guys enjoyed this lesson. Thank you, and feel free to ask questions down in the comments or anything else. If you want to have your friends learn this along with you, be sure to share this with them. And yeah, this will be released out on. Yeah, thank you guys. I'll see you next week or in the office hours. Remember, they are Wednesdays, 1 p.m.